This is a video to supplement the one that we've already done. It's a little bit different. This one's going to show you how to add and subtract fractions, but we're going to add in some diagrams to help us understand what we're doing. Let's start with a fraction where the denominators are the same. For example, let's start with two fractions where the denominators are the same. For example, 3/4 add 3/4. Now, because the denominator is the same, it's fairly simple to add these two fractions together, but let me show you what that looks like as a diagram. Take our rectangle, divide it into quarters, that's 4 equal sized pieces. We shade in 1, 2, 3, that's our first 3/4. Underneath, we can draw another rectangle, again divide into 3 equal quarters, 1, 2, 3. So hopefully you can see we've got 3/4 here, another 3/4 here, altogether we have got 6/4. This is an improper fraction because the numerator on the top is larger than the denominator on the bottom, but in this case we don't need to do any converting because we're just adding the fractions together. Let's move on to a different fraction. This one, you can see the denominators are not the same this time. We've got 3/5 on this side and we're adding 7/10. But we should be able to realise that 5 can be multiplied by a whole number to make 10, and that makes things a little bit easier for us. Again, we can draw a diagram to show this. So first of all, I'll draw 3/5. So I draw my rectangle and I divide it into 1, 2, 3, 4, 5 pieces. They should be equal. Unfortunately, I've not drawn it very well using my iPad. We shade in 1, 2, 3/5. Now we'll try and convert fifths into tenths. So underneath, I'm going to write 3/5 equals how many tenths? I know that 5 times by 2 makes 10, and whatever I do to the denominator, I also do to the numerator on the top, so multiply 3 by 2 and I get 6. If we go back to our diagram, we can see that at the moment it's in 5 pieces. If I divide each of those 5 pieces up again, I end up with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces, and as we can see, 1, 2, 3, 4, 5, 6 of them are shaded in. So now we've converted our 3/5 into tenths, we can rewrite the calculation as 6/10 add 7/10, which gives us 13/10, which is our final answer, which can go up at the top. For our final fraction, we're going to do an even trickier one still. Okay, but if you draw the diagram and follow the working out, it's fairly simple. So we're going to look at, this time, 4/5 add 1/3. Now you might spot this time that the denominators are again different, but unlike the last one we did, we cannot multiply 3 by a whole number to make 5. So we're going to draw a diagram to help us understand what we've got to do. All we do need to do is look at the two denominators, we've got 3 and 5, and draw a rectangle that is 5 squares along one side and 3 squares along the other side. 1, 2, 3, 4, 5 across and 3 down. Okay. This gives us a 3 by 5 rectangle which has got 15 pieces inside it. We should now be able to use that rectangle to work out 4/5 as 15ths. So if we divide our diagram that we've drawn into 5 pieces, this represents obviously the fifths, and we shade in 1, 2, 3, 4/5. So we've now shaded in 4/5 of our first rectangle. And if we count up the small squares, we should be able to see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 of those smaller squares have been shaded in, so 4/5 is the same as 12/15. We can check that by going back to our fraction, and if we see, well, 4 multiplied by 3 would make 12, and 5 multiplied by 3 would make 15. So we've done the same to the denominator as the numerator. So 12/15 is equivalent to 4/5. Now obviously we've only done one of the fractions there, so I do the same rectangle again, so it's a 5 by 3 rectangle, but this time I'm dividing it into thirds. So instead of dividing it vertically, I divide it horizontally, like so. Now my diagram's divided into thirds, 1, 2, 3 thirds, and I need to shade in, when I look back at my original fraction, I need to shade in 1/3, so I shade in just the 1/3 across the top. Again, my new rectangle is out of 15 pieces, and I can count how many small squares are inside that 15. So 1, 2, 3, 4, 5 out of 15 is the same as 1/3, and we can do the same calculation again to check. So 1 multiplied by 5 would make 5, and 3 multiplied by 5 would make 15. So I end up with my calculation in 15ths. So 12/15 add 5/15 would make 17/15. Again, it's an improper fraction, but at the moment that doesn't matter. The answer to 4/5 add 1/3 is 17/15. Now so far we've just shown you adding fractions. Subtracting fractions use exactly the same method, but obviously instead of adding the numbers on top, the numerators, you subtract them. So for example, if we had 3/5, take away 1/5, the denominator is the same, so you just look at the numerator on the top. 3 take away 1 is 2, and the fifths stay the same, is 2/5. If there are any calculations where you're subtracting where the denominator is different, then obviously the first thing you do is, like we've done on the previous examples, convert them so that the denominator is the same. For some fractions you may need to, for some calculations you may need to convert just one of the denominators. For some of them you might have to convert 2 of them, and the easiest way to do that sometimes is to just multiply the 2 denominators together, as we saw on the previous slide. I hope this helps. Good luck with your homework.